All right, look at that. I am actually, yes, I'm going to talk about Constru a bit, but I mainly want to talk about how we got here. I think it's a good year to talk about, how we started the ACM group, which turned into a research and development team, which eventually spun out a company, and I'm trying to summarize all this and then talk about some of the lessons learned. Okay, so let's see. So a bit of a retrospective. So I joined Thornton Tomasetti in 2010 after working at Revit Technologies for some time, and back then, this was sort of the state of the art. There was a project, and there was a software called CATIA where the seat cost $20,000, and there were maybe 2 people in a 600-people firm in the case of Thornton Tomasetti that actually knew how to use this $20,000 piece of software. And it took a lot of time to write these custom scripts to try and define the geometry and the BIM models in a programmatic fashion. I've never liked modeling. Like, I always thought every time I click a mouse button, it's a bad thing. So I always try to, I think modeling is error prone, and will try to, my ambition was always to not replicate anything. So this was sort of a project that had been modeled in CATIA, and then the C work needed to be done in Tekla. And then rather than remodeling the whole model in Tekla, we decided to translate it into Tekla to reduce error. This was for the HOK Sport Basra Stadium. And so the problem with this is it's really not scalable. It takes a lot of time. It takes 1 person per project at least. So luckily, shortly thereafter, we found out about Grasshopper. This was in the summer of 2010, and this allowed us to write some, to prepackage some script components and reuse them. And so later that fall, actually, with the same architect in the same city, also in Basra in Iraq, we got to work on this 30,000-seat soccer stadium. And this was, well, we started working on a competition for it. And we had 5 days. So I actually was out in Kansas City with the architects. And in the first 3 days, we built what you see on the left-hand side, a parametric model where the roof was informed by daylight analysis. And the roof also had a truss model built in, a structural model. Then on the next day, we would use a plugin called Geometry Gym to turn the Grasshopper model into a structural analysis model. We would run analyses, modify the geometry, run analysis, modify the geometry until it worked. And then on the 5th day, we had used one of our early translators between that structural analysis program and Revit to produce the fabrication model, the drawing model. And so this was great. We ended up winning the competition, but I think what really was nice about this was that we realized that hey, there's actually a new workflow, and it's not that difficult to learn, and it can really save us time. And so we went all out and started teaching workshops, and I taught my first class at Stevens and hired a few people. Ben, who's presenting next, was in that class, and so was Nick, who gave the Constru workshop yesterday. And we started a team that summer of 2011. And we trained probably 120 engineers in the first year and worked on all these projects using similar workflows. So, we thought we were revolutionizing the way that our company works, but really, we probably touched upon, at best, 10% of what the company worked on. So it's still not really scalable. It's a lot better than using a 20,000 piece of software that only 1 or 2 people know, but it's still, you can't force a whole company or a whole industry to change the way that they work. We learned that. And so we looked a bit more within, and we decided to start developing tools that are very close to what people do on a day-to-day. So we started building, plugins for all the programs that our engineers use on a daily basis. So this was when the idea of TTX was born in 2012. We realized that there was a great need, like I showed before, for translation between SAP and Revit in the previous example, CATIA and Tekla in the example before. So pretty much every large project always needs some sort of, you can't handle a single project in a single piece of software. So the idea of TTX was that we had a central repository of data and you could read to it and write from it, write to it from any of these 6 different programs that we use a lot at Thornton Thomas Hetty. Like I said, Revit Tools, Grasshopper Tools, Analysis Tools, Tekla Tools. We got really good at it, so good that Autodesk started hiring us for little kind of Dynamo plugins that we've been developing for the last 2 or 3 years. So at this point, this is 2012, we're now 12 people in our group. The group is called Advanced Computational Modeling Group, and we're about 50% billable. And Thornton Thomas Hetty at this point had between 650 and 700 people. So, 6 people out of 650, that's less than 1% of investment in R&D, which sounds like not that much, but it's actually a lot of money. So to give you an idea, the mechanical or the aerospace and automotive industry, a healthy company would spend somewhere around 3 to 4%. And they are a lot better in terms of, they're productizing. We are just a service company, so 1% is a big investment. And so, at this point, like I said, we're 12 people. We cost $1 million or so. So people were asking, is it worth it? And this was also around the time when there was an article in HBR, this came out in May 2012, that our CEO, I think, he really loved this article. Like it went around. This basically started, I think because of this article, we now have an R&D group in our company. This article said, how do you invest, how do you plan your R&D spending and invest it in a way that you get the best return of investment? And it says that there are 3 levels of innovation: core, adjacent, and transformational. And it essentially says that core means, basically what we did back then, like just automating our day-to-day work, making it a bit better. If everybody else switches from fax to email, then that's called core innovation, because if we don't switch to email, then we're gonna just get lost. So that's just like keeping up. Then adjacent innovation means maybe take what you already know and apply it to a slightly different type of project, or try a new piece of software on the same kind of project that you've been working on. So like try and experiment a little. And then transformational is when you go and you're Lamborghini and you're producing tractors, and all of a sudden you're starting to sell sports cars, and you do something that's quite far removed from your original business. And so we were basically investing 100% of our time in core innovation at this point. And it says that a healthy distribution would be 70% core, 20% adjacent, 10% transformational. So again, they asked, is it worth it? And so we asked ourselves, let me work it, and we put my thing down, flip it, and reverse it. And we came up with some analytics to basically answer that question for the leadership of the company. And this is a screenshot. I don't know if you can see it, but this shows the software usage of our plugins that we had written over the years for the year of 2016. And it says that our Revit tools had been used almost 12,000 times. So if we can't really say what the value is, but if we assume that one tool usage saves an hour, then there would be 12,000 hours of time saved in Revit alone. We had a ton of different tools, so we could easily prove that we had 40 or 50,000 tool usages per year. So the question was very quickly answered, and it was worth it, and we were fine, and we could continue to grow the team. But I think what this is really important, and I mean, we have the same thing now for Constru as well, and it's really important. It really helps us as a company to understand what kind of tools are important. Like if we develop something and nobody uses it, then we might as well not develop it or not maintain it. So what are the tools that are popular? And also which offices are using what kind of tools and which offices need training. So I remember there was an early chart that we had where we went around and gave TTX training, and there was an office with 0 TTX usage, and all of a sudden, I think Ben and Nick went out there, or Ben and Matt, I forget, and a few months later, they had more than 50% of the office was using that piece of software. So, so you can really just identify training needs. So you know what people need, and you also know how to best train them. And so this was really fundamental for our group to be successful. All right, great, but now there was this whole idea of like core and adjacent and transformational. So this was not creative at all. What we were doing, I mean, sorry, this was cool and all, but it wasn't creative enough. So leadership said, please, you know, be a bit more transformational or adjacent. And so this was then when we formed the core studio. So the idea that we used to be a computational modeling team, and we added a research arm to that, and then, you know, we renamed our group to Core. And the way that it worked is that it was driven by the very top, and essentially a R&D fund was made available to all staff. And anybody who has a good idea or a bad idea, anybody who has any idea can suggest it. And then our CEO and our chief marketing officer and some other very high-level people that, you know, have a lot of influence in the company review every single proposal, and they decide who gets a lot of time and money. And I think this is important that it comes from the top. I think if this comes from the bottom, it's not going to go anywhere. But if, you know, a project manager in Chicago or in whichever office says, well, my staff is not allowed to work on this because they don't have the 200 hours that you allotted them, then the very top can sort of influence that a bit. And so we started teaming up with MIT. We started working on 3D printed structures. I'm sure you guys have seen the shop. Miami Art Pavilion. This was just one example where we already owned 2 3D printers, and we have been for years, or probably almost decades, been going to job sites where there were unsafe conditions, bridge collapses, building collapses, and scanning it and figuring out the damage. And then one day, Justin, who was in our group at the time, took his camera to one of the sites and started snapping pictures and turned it into a 3D, you know, he used the photogrammetry software, turned it into a 3D model. And he did that in one day, and while it took more than 2 weeks to process the point cloud that the laser scanner produces. Laser scanners cost $40,000, drones cost $2,000. So we went and bought a drone, mounted a camera, started flying around buildings. Actually, this was one of the buildings that we captured. I don't know if it was legal, but now it happened anyway. But we very quick, I mean, this was a very shallow learning curve to get to something meaningful, to get to meaningful 3D data captured by photographs. And so a year later, there was a parking garage collapse in Dallas where a big pile of dirt that was stored on top of the deck. It rained for once, it absorbed all the water, and it got really heavy, and you can see what happened. And so this was a bit unsafe to go in. And so we took a drone out there, flew it around, turned it into a 3D model, and used that to investigate how to rebuild the structure and what the damage was. And so this was so successful that, you know, over less than a year of owning a drone, all of a sudden we now have drones in New Zealand and in various offices in Europe, in Chicago. And we have, I don't know, probably 7, 8, 9 jobs already done today. So it's a $2,000 piece of equipment, and it's a very low learning curve. And so at this point, we already built a little crawl space robot that we can also use for this kind of investigation. So it's, you know, it's R&D instantly turned into a business. Okay, great. So I think we're getting somewhere. We have now a way to get the whole company to come up with ideas. We have, you know, the leadership is on board. This is super important. But we're still, except for MIT and Branch and a few others, we're still very much internal. So we decided we want to play with others too. And so this is when the idea of this symposium was born. So in 2013, we started our first symposium, and then in 2014, we introduced the first hackathon. So the reason why we did hackathons is, you know, talks are inspiring. I think today is going to be a really great day, and I think we're going to go away, and we're going to be a little overwhelmed and super inspired, but on Monday, we'll be back in the office, and we'll be back doing whatever we did last Monday and the Monday before. So it doesn't last, quite possibly. And so, but the thing is, if you attend a hackathon, actually, may I ask who's coming tomorrow? Maybe almost 30, 40%. So if you attend a hackathon, you know, the ones that we have, we get locked in a room for overnight, 27 to 30 hours. We team up with people that we don't know. Like, there's the extra points for teaming up with people that are not your coworkers. We work on something that we could never work on our own. So as an example, in the 2014 hackathon, we wanted to build a 3D viewer, a 3D web viewer, And we had no, like Thornton and Tomasetti, we had no idea how to do this. We teamed up with people from Autodesk, we teamed up with people who knew WebGL, and we built a 3D web viewer over the course of 27 hours. So you can really build something that you couldn't otherwise. And you can collaborate with people that are otherwise, you know, your competition. But for these 27 or 30 hours, they're your friends. And so I think this is really important. And to date, we've generated close to 40 open source projects. These are a couple of them. So this was 2014. There was a 3D viewer. And then there was also this, pollinator tool that let you, in parallel, run daylight analyses in the cloud. And you could then filter through the results using this parallel coordinates system. So that was 2014. And then shortly thereafter, just because we got the inspiration from all these people working at the hackathon, we decided to build Design Explorer. Actually, Mustafa built most of this while he was working with us at Core Studio. And the idea is that we can generate so many design options from tools like Grasshopper and Dynamo. And what do we do with all that? So this is a way to export them all, and then you see all the different parameters of that model at the top, and you can filter through them. And then you can, once you said, okay, I want to find all the models where criteria A, B, and C are met, it kind of filters those for you, and then you can look at them in 3D. So again, this would have not happened if it wasn't for the hackathon in 2014. So this is an open source project. I was in Atlanta last week, and I ran into somebody who said they were teaching this to their students right now. Like it's still going, 3 years later. So okay, I think now we have a bit of a recipe. Now we know how to come up with ideas, how to vet them, how to realize them, and also how to, in a short amount of time, really build something, build 10, 15 products on a weekend. So I'm hoping that there will be 15 open source projects tomorrow. I'm sure there will be, actually. There are a lot of people coming. And so then in 2015, this was pretty much 2 years ago exactly, we had a big merger. Thornton Tomasetti had about 800 employees. Weidlinger had about 400. And we merged with them. And as part of the agreement was that a accelerator was going to be formed, an independent company that would take some of the IP that Weidlinger and Thornton Tomasetti have created over the years and are continuing to create, and spin those things out into individual companies. It's a bit like Google Alphabet, maybe slightly smaller than that, but the same idea that there's kind of a shareholder company and then all these different side businesses coming out of it. And so that was that. And so we spent a good amount of 2016 just looking at everything that we've ever worked on and talking to users and starting to build prototypes. And eventually, in the winter of 2016, early 2017, we spun up the 5 different firms. One of them is PCFlex, which is a finite element software. Another one is Hummingbird Kinetics. So this is actually a technology that NASA created for damping, and they didn't quite, I guess they didn't quite know what to do with it. I'm not American, so I wasn't involved. I wasn't allowed to communicate, but that's kind of what I got out of it. So they approached us and they said, hey, we have this technology. I think it would be great to use in buildings. And so we took that and we started a building damper company. And it's already being implemented in a building in Brooklyn right now. And then the last one is Constru, which I'm going to talk about from now on. I put this in, how long? 19 minutes. So maybe just to slow down a bit, because I realized this was a lot of stuff, and I'm going to completely switch topics now. So I don't know. It's early. So why did we decide on spinning up Constru? So we looked at different tools that we had, and we realized, well, it was one of the first pieces of software that we'd ever developed, and the reason we developed it was because there was a great need, structural interoperability. And so what is Constru? It's basically a tool that lets different programs talk to each other in a common language. And of course, without Constru, we wouldn't be able to be here in this building right now. That's not true. But what I'm trying to say with this slide is a building like this, part of the building is designed in RAM, another part is designed in SAP, all of it is documented in Revit, maybe some of it is detailed in Tekla. So any building that is medium or complex cannot just be designed in one piece of software. And so that's why we needed Constru. And so we essentially took TTX and completely rewrote everything about it. So now it's a web-based software. It has a central data repository, just like TTX did. But it also keeps track of your project history. So every time you upload something, it creates a new instance of a model, similar to how when you use Google Docs or anything like that, it keeps track of the history. And the other thing that we learned from TTX was that people really want to control what kind of data they exchange. So just sending somebody an IFC file or like a DWG file gets the job done to some extent, but oftentimes it's not controlled enough. And the other thing that also we learned from TTX is we need full transparency. We need to understand exactly which elements get added or removed or not deleted or not removed, even though we expected them to. So, so that's basically what it is. So I'm going to show this short video. Yeah, there we go. So for example, you may start a project in Revit. You may push it into Constru. You may then bring it into ETABS, make some changes, and then bring it back into Constru and back into Revit. And this is just kind of, for you to see what the UI looks like. So this is the Revit UI. It's just, we have essentially 7 different plugins. They all look like this. And you can always see which kind of elements and how many of them are about to be added or deleted. So we just uploaded this model. And you can see this is our 3D viewer. This was actually based on the one that we started at the hackathon back then. And there are different visualization options. But so now we're in ETABS. We're downloading the same model. We're going to make a change just to one of the columns, just for demonstration purposes. And we're syncing back into Constru. And now you can see in the viewer that one of the elements is orange. So one element has been changed. And now if I bring this back into Revit, it tells me that one element has been updated in the transformation. So you can really exactly understand how many elements were added or deleted or changed. The other thing, like I said, is change management. So we've been working a lot in software, in software development, like I said. And at some point, Ben made us use GitHub. Once we were more than 2 people collaborating, there was no more, just saving it on the P drive and sending somebody a link to the JavaScript file or to the CS file. And once we were on board of that, we thought we can never go back. So essentially, GitHub is, Git was created just to manage large open source projects where you have multiple collaborators all working on the same project that don't spend 5 hours a week in these BIM coordination meetings. Like they work, in different parts of the world, and they just collaborate on a piece of software, and it's all just something like Git or some other versioning system that lets them collaborate. So we brought the idea of Git into, we developed that for Constru, so that we can now have versioning of BIM models. So every single time, imagine sending 10 people a Word document and telling them all to make changes and sending it back to you. And if they don't turn on something like revision control, there's no way. It's really difficult to figure out who changed what. So if we do turn it on, then it's really easy. And so I'm just going to show the UI for this. So basically, every single time I upload my model, I can see sort of a snapshot in colors of what has changed. And then if I enter one of those, I can go to my change view mode, and I can see how a building has changed between today and the last time I uploaded. And I can also compare today's version to an earlier version, maybe 30% DD compared to 50% DD. I can then create reports, and I can send them to my collaborators so that they can also review what has changed. So today we send somebody a BIM model. If we're good, we send somebody a BIM model every time at every major submission. And then we're like, good luck figuring out what changed. So with this, we can send them this, and they can actually see what has changed. So that's kind of the idea. So a few other features. I'm very new to actually being, on the sales side. I'm not a salesman, but being on this side. Like I'm used to presenting projects. I'm not so used to presenting features of platforms, but this is my first attempt. But so another thing that we have built in is the idea to compare different files. So essentially, what if somebody, like if two different engineers work in two different models, or like, for example, this example, is the fabrication model still up to date with the construction model? So we can just overlay the two in Constru and we can see what is different geometrically. Or are we still working on the same grid and slab edge information? This is a problem all the time. From the engineer's perspective, the architect changed the slab edges, and we don't find out about it until 2 months later, and everything is out of sync. So we can use Constru to just compare what is different geometrically. Let's move on. And then the other thing is, of course, the idea of just combining information from different files. So in this example, the roof was developed in one piece of software, and the rest of the truss was analyzed in another piece of software. So yeah, that makes sense, merging. But then also, what if we want to apply certain filters? So what if we only want the columns from that from that model, but not the slabs? So we have built in the ability to filter out elements. Or what if we only want certain attributes? What if we want columns, but we only want the material and the force values, but not the geometry? So we can also filter out which attributes are being translated. And so then once we released this in February, and it was extremely buggy, and we just wanted to get this in people's hands and see what they think. And quite early, it became apparent that actually apples and oranges are not the same. So a Revit model should not look the same as an ETABS model all the time. Quite often in ETABS, people like to work, or ETABS actually automatically meshes the model for analysis purposes. But then in other analysis software or documentation models, we don't want the meshed elements, we want the whole element. And so we built this in, that you can translate a meshed ETABS model into a holistic Constru model. So you can see that here, like a 16-piece wall in ETABS may turn into a one-piece wall in Constru. And then the last feature that we just released yesterday is the idea of model repair. So very often we see people starting in Revit, and then they try to run an analysis from that, and they realize that the model wasn't connected right, or it just wasn't modeled clean enough. So they end up remodeling it, just for analysis purposes. So this is a bit like text, I forget the word now, but anyway, I'm just going to show the video. This is a bit like autocorrect, spell check for a model. So this is, again, a really quick demo. We're going to create a new model in Constru. We're going to upload something that looks pretty good from Revit, but in fact, it's not fully clean. And then we're going to fix it, and then we're going to run the analysis. And you can see it is fairly quick. So we have this truss in Revit. We upload it into Constru. It tells us what is changing. We can now look in Constru, and there's now a new tab called Repair. And it does run an analysis, and it visualizes some nodes in red that only have a single edge connecting to it. So then we can set certain conditions for repair, and then we can say, preview, show me what would happen if I submitted this, and now we can see all the colors changing, so the nodes are much more connected. So if we like it, we can save this, and it's creating a new version. So we still have the old version in case we don't like anything, and we can revert back. So now this is ready for analysis. So I'm just going to stop here, but you get the idea. So we have the other thing that I think has been really great so far is that before we only, at Masseria, we only had one type of customer. And now all of a sudden, there's somebody from India, Bureau Happel, there's somebody from Australia, from Arab, there's somebody from a German firm. So now all of a sudden, we have international firms all using this tool, and it's a whole different challenge to, we just realized that the Revit plugin doesn't work in German. So it's all about language settings and this kind of stuff that we never had to deal with before, but it's been a good ride so far. So I'm going to stop here. Thank you very much.